Welcome again to my YouTube channel. In this tutorial, I'm going to teach you about the gradient and equation of a straight line. So specifically, I'm going to teach you the gradient of a straight line, the introduction to this chapter. Then the next video I'm going to upload about the content, other contents which are found under the same chapter. Now, without wasting time, I just want to introduce gradients. We want to understand the meaning of the word gradient. Now, in this case, now let us assume that we have a technician. A technician is to climb a ladder, top of a wall. Assume that the ladder now is top of the wall. To climb a top of a wall using a ladder for repair workshop. Now let us assume that a technician is to climb the top of a wall. Is to climb the top of a wall with the help of a ladder. With the help of a ladder, which is the top of the wall now is 4 meters. We assume that the top of the wall, the vertical height of that wall is 4 meters. Top of a wall 4 meters for repair as shown below. Now, it is not that easy to climb the top of a wall with barefooted or using only your body. You must get a help from an inclined plane, that is a ladder. Now we are going to sketch the ladder and also the wall of the wall that this technician is climbing using the ladder, which ladder must be placed in a slanted position with the wall. Then the ladder will always make an angle, a certain angle with the wall, which will always be less than 90 degrees. Now to have a sketch of the ladder and the wall. Now assume that this is the wall. I'm drawing a wall, vertical height to represent the wall. Then this wall is 4 meters high. The height of the wall is 4 meters. Now the ladder will be placed at an inclined angle with the wall. It means that the ladder will be at an inclined angle. Now this 4 meters is the length of the wall. And we have the distance from the foot of the ladder and the foot of the wall. Now this is our ladder at this position. Then we have this distance from the foot of the ladder and the wall. It is 3 meters. Now we have the height of the wall and the distance between the ladder and the wall, the foot of the ladder and the foot of the wall is 3 meters. Now we can see now from the sketch that we have on the board, the foot of the ladder and the wall are 3 meters apart. But we have the angle which is formed, the angle between the ground and the wall. This angle here is always, we assume it that it is 90 degrees, this angle. Now, the ladder and the wall is making this angle here. We have the ladder and the wall meeting at that particular point, the top. It is making this angle. We can call this angle an angle theta, but we're not going to use it now. Now, when the ladder is placed at an inclined position, less work is being used to climb up a wall. Now, from the diagram here, we assume that now, not that we assume, we have a right angle triangle. This kind of triangle is called a right angled triangle. Now, with the help of the ladder, this technician is going to use little energy to climb up a ladder. Now, for every steps the technician makes while climbing up the ladder, we have, he's going to climb up the ladder, he's going to move in 2 dimensions. That is the vertical dimension. At the same time, he's moving in a horizontal dimension. As a result, the stiffness of this ladder, the stiffness of the slope now the stiffness of the slope is the same as the gradient, which is the same as the stiffness. Now, in this case, to find the slope of the ladder, now, how much work is done? So the stiffness of the slope is always equal to the change in vertical component over the change in the horizontal component. Change in horizontal component. That is the slope, the stiffness of the ladder. The slope, that is the gradient. So this slope, which is the change in vertical component, the ratio of the change in the vertical component to the change in the horizontal component, this is what is known as the gradient of any given line. So the slope represents the gradient now. Now, from the example that we have here, to find the gradient of the ladder, the gradient is equivalent to the change in the vertical component. So the vertical component is 4 meters. So that is the same as 4 meters divided by the change in the horizontal component, which is 3 meters. So the gradient of this ladder is the same as 4/3. So this is the gradient of the ladder. Now, without much ado, the gradient of the ladder now, from the diagram above, from this diagram now, we can say now the gradient of any given line, straight line, is equal to the change in vertical component of the line, the ratio of change in vertical component to the change in the horizontal component. That is known as the gradient, which is the stiffness of the ladder now. Now, let us consider another figure below, which is a straight line in a Cartesian plane coming from the origin, that is 0, 0 on the Cartesian plane. Then it is passing through a point P whose coordinates is 4, 3. Let me have a sketch on the board. So the sketch is, consider we have in the figure below, let me just tell the question. In the figure, below, OP is a straight line through the origin. So you have OP is a straight line. It's a straight line through the origin. Full stop. The coordinates of P is 4, 3. So P is 4, 3. That is the coordinate of P. It's a point on the line. Now we have a sketch on the Cartesian plane, which we have the O and point P. But the coordinates of point P, it is 4, 3. The 4 is the x component and the 3 is the y component of the point P. So I'm going to have a sketch of that Cartesian plane. So this on the Cartesian plane represents the x-axis. Then you need to put the arrows, then the origin is that point, the origin. Then the vertical axis is known as the y-axis. So this is the y-axis. Now assume that now on the x component, we have point 1 at this particular point. Here is 1, 2, 3, 4. And on the y component, the y scale, axis scale, we have 1, 2, 3. Now, to plot these points 4, 3 on the Cartesian plane. So the x component is 4 and the y component is 3. So if the two meet, we have the point P is approximately at this particular point. So I don't have a scale. I'm not sure that whether it will have 3, 4, but just a sketch. So this is our point P, whose coordinates is 4, 3. Now I can join P to the origin. Now, that is line OP. So we have point O and point P. Now, line OP, we have the vertical component of line OP. So in this case, we have an imaginary triangle here, which is incomplete. So you can drop another point from point P to touch the x component at a point, the x-axis at a point. That is the x-intercept. Now in this case, this angle here is 90 degrees. From line OP, we have the vertical component of the line and the horizontal component. So the vertical component represents the y-axis and the horizontal component represents the x-axis. To find the gradient of this line, we are going to apply the same formula, which is equal to, so the slope, which is the gradient, is the same as the change in the vertical component, over the horizontal component. Now the vertical component is the distance from this place where we have the x-axis to point P. So the vertical component was 3 units, and the horizontal component here is from the foot, that is from point O, where we have the last reading on the x-axis, which is 4 units. So the gradient of this line is equal to the vertical component, which is 3 units over 4. So this is the slope of the line that we have just drawn on the board. Now, in summary, we can find the gradient of any given line by using the formula now. We'll now assume now that we don't have point O, which is 0, 0. We assume now the coordinates of point O, we can call it x1, y1. And the coordinates of point P, we call it x2, y2. Now, using the coordinates at 2 points on the line given on a graph, we can use the formula, the gradient of that given line is equal to the change in the vertical component. And the vertical component in this case is represented by the y-axis. So we're going to take the y components of the coordinates, we subtract them, and then over the x components of the coordinates, then we subtract. So this is equal to the y2, change in y, the y component, which is the vertical component, over the horizontal component. So the y component here is y2 at point P. So y2 minus the x component here at point O is y1 over, the y component at point P is y2, and the y component at point O is y1. The x component at point 2 is x2 minus the x component at point O is x1. So when I'm given the coordinates, any two coordinates along the line, we can use the coordinates. We usually use the coordinates to find the gradient of that line. We just take any two coordinates along the line. Now, for example, find the equation and find the gradients of the line passing through the following points. I have a question like find let me have it, find the gradients of the equation of the lines passing through the following points. Of the lines passing through. So the first points we have is point A, which is 2, 3. Coordinates of A, 2, 3, and B, coordinates of point B is 5, 6. 5, 6. Then B, the second points, P, 2, -5. P, 2, -5. And point Q, 2, 3. Then the third point C, the third point set of points we have I, which is a quarter, a third, and another point coordinates we have J, a third, a quarter. Now let me start by solving the first example on the board. Find the gradient of the line passing through the following points. The first points we have point A, whose coordinates is 2, 3, and point B, whose coordinates is 5, 6. Now these are the given coordinates of the first set of points. So I can call this point A, the first coordinate here, which is 2, I call it x1, and the y coordinate I call it y1. Then B, this one 5, I call it x2, then y2. To find the gradient of that line AB, now we apply the formula now. The gradient is equivalent to y2 minus y1 over x2 minus x1. So the y2 in this case is 6 minus y1, which is 3. So we have 6 minus 3 over x2. x2 here is 5 minus 2 over 5 minus 2. So this one is 3 over 3, which is equivalent to 1. So the gradient of the line AB is 1 from the example. Now let me go to the next example. Point P and Q. So find the gradients of line PQ. So we have the coordinates of point P and the coordinates of point Q. So the coordinates of point P, the x coordinate, let me call it x1. Then the y coordinate, I call it y1. Here the x2, y2. Again, you apply the formula of finding the gradient of a straight line. So the gradient again is equivalent to the y2 minus y1 over x2 minus x1. So this is equal to y2 here is 3 minus y1, that is 3 minus y1, which is -5, over the x2. x2 in this case, we have 2 minus x1, 2. So 3 minus -5, that is 8. 8 divided by 0. So I guess that one is 0. So the gradient this line is 0. It means that it is a line parallel to the y-axis, either y or x-axis. So it is the gradient is 0. Then we go to the last one, which is part C. Now part C, we have I and J. So we want to find the gradient of lines IJ. So again, gradient is equal to the change in vertical component y2 minus y1 over x2 minus x1. So I can call this point I x1, y1, x2, y2. So y2 is a quarter minus y1, which is a third, over x2, which is a third, minus a quarter. So this gives you, so a quarter minus a third, that is minus 4. That is minus 1 over 12 over 1 over 12. So the answer is -1. So thank you for today. Subscribe to my channel for more updates and for more videos. Thank you.